Hello guys, welcome to another section of Math. X is equal to square root of root 5 plus 1 divided by root 5 minus 1. And then the question is saying when x is equal to this expression here, that is 5x squared minus 5x minus 1 will be equal to what? Provided what the value of x is what? This one, or provided the value of x is was known. So if x is equal to this expression here will be equal to what? Now this problem here is um very simple, and this one there's no trick here. It's a straightforward question. All we have to do is to just pick this expression, put the value of what x into the expression, and find the value what at the end of the day. So if x is equal to this one, then what if x is being squared and multiplied by 5? Subtract 5x from it, and then also subtract 1 from it. What are you going to get at the end of the day? So it's just a matter of just putting this one into this what expression here, and then finding your value at the end of the day. But that is what we are going to do actually. But before we put this one into this expression here, square root of root 5 plus 1 divided by root 5 minus 1 is not, it's simple, but it's not that simple, because when we put the whole of this thing inside this expression, it shouldn't take care, it might confuse you, or maybe you might find it difficult. Not necessarily difficult, but maybe due to the algebra aspect, the calculations that you might come across, you might encounter some difficulty. So what should we do then? If we put this whole thing into here, is going to maybe make the problem a little bit worse. What should we do then? Well, x is equal to square root of root 5 plus 1 divided by root 5 minus 1. Let's leave this one for now. So all we have to do is just, I think we should work on this one a little bit. I mean, we should simplify it a little bit before we put it into the expression, so that computing the value of the expression will be what very simple for us and easy to understand compared to taking this whole thing. I'm not saying when you take this whole thing and then you put it into the expression, you are wrong. We can take this whole thing here and put it into the expression and then compute, provided your algebra aspect is what good. If only you can do the algebra, I mean, you can deal with the square roots that is involved very well, you got no problem, you can do it that way. But to make it very simple for us, let's first try and simplify this one to its lowest form before we put it into the expression. Doing so will make finding the value of this expression what very simple. Okay, but the question is, how are we going to reduce this one? Well, to find out, let's get started. First, let's write our solution. All right, so as I said earlier on, let's put this one somewhere for a while, and then let's work on this one to reduce the value to its lowest what form. Okay, square root here, and all of them is being what there's another square root on all of them. Okay, so how are we gonna do that? So first, let's bring this one down here, work on it a little bit, and see what we are going to get. Okay, so let's bring it down here. All right, now here, what is inside the square root is what we call what set. Set. Here, this one is a set. This one is a set. This one too is what set. So to work on this one here, we have to apply the idea of what set. That is, under set, if you want to there is something called rationalization. That is, if you want to take a radical or maybe a set from a denominator's position, what we do is what we rationalize the denominator. To rationalize the denominator um, simply means you are to take the set from the denominator's position and put it into what the numerator's what position. So, and it's done in two ways. One, if it is of this form, we rationalize by using what h conjugate. When I say h conjugate, is what I mean by h conjugate is you are to multiply it by its what opposite. The opposite of root 5 minus 1 is what? Root 5 plus 1. Okay, and the other way is that if there is no minus 1 here and the denominator is just root 5, you just take that root 5. This one, you don't conjugate it. You just take that root 5, multiply the numerator and denominator by that root 5. Okay, but here this one is being separated by what? Minus, so we have to do it by its what conjugate, so that this one will be all affected at the same time. Okay, so applying the idea here, we are going to rationalize what is inside this square root. Okay, yeah, okay, so as I said, we are going to rationalize using what this one, and to do so we are going to take the opposite, which is what the conjugate of what this one, that is root 5 minus 1. So the conjugate of root 5 minus 1 is what? Root 5 plus 1. So you're going to multiply this one by root 5 plus 1. It's not this root 5 plus 1, but rather the opposite of this one. So please don't get confused and don't think we are using this one. No, we are using this one, but we are multiplying it by its opposite. The opposite simply means not this, but the opposite of what? The sign separating the two numbers. So if this one is plus, it will go minus, and if this one is minus, it will be what? Positive or plus. So here is minus, so it's going to be what? Plus. Okay, good. So to take this one from this denominator's position, you're going to multiply the numerator and this denominator by what? The conjugate of this one, which is root 5 plus 1. Okay, so let's do that. Good. Now when we do that, there is what we are going to get. That is root 5 plus 1 over root 5 minus 1 times root 5 plus 1 over root 5 plus 1. This one is here because of this that we want to eliminate. Okay, good. So what are you going to get? This times this one and this one are the same. So this times this, you're just going to expand it. You're just going to bracket it what first. Okay, I know why you are going to bracket it, and you find out by the end of the day. You're not just going to expand it, but we just bracket it. But this one and this one are the same. So just write into bracket root 5 plus 1 all squared. Now when we come here, this times this, they're not the same, so we just bracket before we what. As for this one, we open the bracket, but first let's multiply before we open the bracket for it. Okay, so going to be this one times this one, and also this times this one. Okay, good. As I said, you're going to open the bracket for what? The denominator, because that is where our focus is. That is where we want to eliminate. Okay, good. So looking at this one. This one is like expansion of two binomials. Yeah. So to expand this, we are all familiar with that. So I will skip some process. We're just going to the process that I'm going to skip. I'm just going to say it with my mouth, but you not see what the workings here as you are seeing or these ones. Okay, but you see the result or there. Okay, so they you just pick this one, multiply it by the whole of this. This times this will give us what? 5. And then this times this will give us what? Root 5. Why? Because this times this are the same. So it becomes something like this. And this one, provided there is square root on the whole of this, these two could have taken it away. So this times this will become root 5 all squared. And that too will take away the square root sign, and that will give us 5. And this by this will give us what? Root 5. Now let's pick this one. Minus 1 times root 5 give us what? Minus root 5. So 5 plus root 5 minus root 5. You see, root 5 plus root 5 minus root 5 will go away. And to be left with 1 times 1 will give us what? That is minus 1. So actually, when we expand this bracket, we are going to get 5 minus what? 1. 5 minus 1. Okay? Good. Now, 5 minus 1 will give us what? 4. 5 minus 1 will give us what? 4. Good. Now here, remember I said we are not going to expand it. And you're going to find out why I said we are not going to what? Expand it. Okay. So here, x is equal to square root of into brackets root 5 plus 1 all squared divided by what? 4. You see, the rationalization has helped eliminate the root or the radical from what? The denominator's what? Position. Okay. Yeah, so anytime you have said like that, if you want, and you want to rationalize it, that is how we go by it. Okay, so here what we are going to do is that, looking at what we have gotten, it seems that we can rewrite this and this in such a way that this one will go off. And how are you going to do that? This one is what? Root 5 plus 1 all squared. And this one is what? 4. Meaning we can also write this 4 as well, 2 squared. And since we are having square on the top, and also you're having another square on the down or the bottom, we can write that we can factor the square outside. That is what the power 2 outside. And when you do that, you're gonna get root 5 plus 1 over 2 all squared. And that will what? Take away this square root from it. Okay, so what you are going to do is that we are going to write this one as square root into bracket root 5 plus 1 over 2 bracket close all what? Squared. It's not the whole of this square root squared, no, but rather it is what is inside the bracket in the square root is what? Being squared. Okay, so let's do that one. Good, this is what I mean by what I've said. Okay, now you see this one is so big. You see, when we expand this, when you open the bracket for this one, you're gonna get the same thing as what? This one. Okay, so when you write it this way, this square root and these two will cancel out, and whatever we get will be for the value of x in its simplest form. Remember, all these that we have gotten along the way are values of what? X. Any of them, when plugged into the expression, will work, provided you can deal with what? The algebra aspect. But we are, we want to get the simplest form or the simplest value of what? X. Okay, that is the lowest what value of what? X. All of them are values, but we want to get what? The simplest form, or maybe the lowest term of what? Or the lowest value of what? X. We want to reduce it to what? Lowest term. Okay, that is why we are doing all this. We can put the either this or maybe the main one into the expression. We get the same answer at the end of the day. You can do that, but here first I prefer we should simplify it before we plug into the expression. Okay, so here these two and this one will just what? Cancel out, and x will be equal to root 5 plus 1 over 2. Now when we put this one into the expression, you see this one is more easily to work with as compared to the whole of square root of root 5 plus 1 divided by root 5 minus 1. That one, if you don't take care, you won't be able to do. I'm not saying you can't do it. You will be able to do it, provided if your algebra is good, or maybe you can do it. By here we are just going for the lowest step. So you see, after simplifying, after reducing the square root of root 5 plus 1 over root 5 minus 1, this is what we have gotten for the value of what? X. Okay, so we are going to put x equal to root 5 plus 1 into what? The expression, and then we find the value of the expression at the end of the day. Okay, so put the value of x, which is this one. Don't pick this. If you want, you can pick this one and you still get your answer. Just that you are going to do a lot of what? Algebra compared to the working that we are going to do when we put this one into the expression. Okay, all because of this square root of this visit. Yeah, something like that. So now let's put this one into the expression and find the value of the expression. Okay, so the expression is 5x squared minus 5x minus 1. So here we're going to replace x with what? Root 5 plus 1 over 2, and here to the same thing. Okay, good. All right, so well, what are we going to do now? Let's open the bracket for this one. Yeah, let's open the bracket for the back. This time we're not going to write this one as root 5 plus 1 all squared. This time we are finding the actual value, so we are just going to expand everything. Okay, every bracket that we come across, we just open it and find out if we can subtract, add, or eliminate some. Okay, so let's open the bracket. This one being raised to the power 2. Let's open the bracket and then find out what we are going to do at the end of the day. We are not multiplying this one by this yet, but we are just going to deal with this one first before we multiply this one through. Okay, good. Now when we open the bracket for this one, this one times itself, this is what you're gonna get. You're gonna get 5, and it's so because here to open the bracket for this, so this one is the same thing as root 5 plus 1 all squared divided by what? 2 raised to the power 2. 2 raised to the power 2 will give us this 4 here, and then to expand root 5 plus 1, when you expand, this is what you are going to get by That is how you're going to do it. Just pick the first one and then you square. So it's just going to be root 5 all squared, and that will give you what? 5. And then you pick this one, multiply it by this, and then this. So that is going to be 2 times root 5 times 1. That will give you 2 root 5. And then the last one, you're just going to pick this one and then you square it. And when you do that, you're just going to get what? 1. You're going to get what? 1. So when you expand this one, you're going to get 5 plus 2 root 5 plus 1 all over 4. Okay, so here we just leave it as this. And it's so because we want to ensure uniformity. Yeah. When you expand this, we expand this one as well. When you do this one and then we open the bracket for this one, it will be something else. Okay. So now let's open the bracket. Good. Now when you open the bracket, this 5 here, this cannot cancel out with this, so this will multiply the whole of this. And right when you do, you're gonna get 25 plus 10 root 5 plus 5. 5 times 1 will give us what? 5 all over 4 minus, now this times this one will give us what? 5 root 5. And then this time this one will give us what? 5. Please don't get confused with this minus sign here. Yours, you can choose to do it as minus root 5 minus 5. And you're still going to get the same answer as we are going to get for this one. This one, I choose to take this one as positive and multiply it with this one, because at the end of the day, what we are going to do in the next step is going to what? Include this minus sign here, which is going to affect all of them at the end of the day. Okay, so expanding this one, I decided to ignore this one and then multiply this one through. Okay, just to avoid not confusion, but just to make it very simple. Okay, all right. So now what is the LCM? Now the whole of this over 4, the whole of this over 2, and then it's minus 1. So what is the LCM? To solve this one, we have to find what? The LCM. What is the LCM? The LCM here, let's see, here is 4, 2, and here is what? 1. So the LCM here is what? 4, because 2 can go into 4, and then 1 can also go into 4, and 4 can also go into what? Itself. Okay, so we're just going to pick the 4 as what? LCM, and then we just add all the numerators together and see what we are going to get at the end of the day. Okay, good. Now when we do like that, you're gonna get 25 plus 10 root 5 plus 5. And here is so because here it was 25 plus 10 root 5 plus 5 all over 4. And now here is the case, the LCM is 4. So 4 divided by 4 give us what? 1. And 1 by 25 plus 10 root 5 plus 1 give us what? The same thing as this. Okay. Now when you go to the other one, the other one is what? Root 5 root 5 plus 5 all over 2. Now 2 can go into 4 how many times? 2. But this time it's not just 2 but what? Minus 2. You see, so whatever we get, we just multiply it by what? The numerator. Okay, so you see, then I get minus 2 multiplied by what? The numerator, which is what? 5 root 5 plus 5. Now 1 can go into 4 how many times? 4. And 1 by 4 give us what? Minus 4. Okay, so now let's open this bracket. Now when you open it, you're going to get minus 10 root 5 minus 10. 2 times this will give us 10, and also 2 by this will also give us 10. But because this 2 is negative, just going to we are going to get minus 10 root 5 plus minus 10. Okay, good. Now, this is what you have gotten so far. 25 plus 10 root 5 plus 5 minus 10 root 5 minus 10 minus 4 all over all 4. That is after opening all this bracket. Okay, here let's find out what can we do. Well, any number that can be eliminated or cancel out. Well, you can see that here we are having 10 root 5 and it's positive. But when you come here, you're having the same 10 root 5 but it's what? Negative. So this and this will cancel out. And when that happens, and when this and this will cancel out, we are left with this, this, and that. And all of them are just whole numbers in the numerator's position. So after that one, we can easily add them. Okay, so 25 plus 5 will give us what? 30. Minus 10 minus 4 will give us what? Minus 14. Okay, so we're gonna get 30 minus 14 all over all 4. Alright, so 30 minus 14 will give us what? Well, let's find out. Let's put this one under here. 0 minus 4 will give us what? That will be borrow 1 from here, add it to this one, become 10. Subtract 4, you're gonna get 6. 2 minus 1 give us what? 1. So you're gonna get 16 over 4. 16 over 4. 16 over 4. Now, 16 divided by 4 will give us what? 4. 4. 4. 4. Okay. So, therefore, if x is equal to square root of root 5 plus 1 over root 5 minus 1, then 5x squared minus 5x minus 1 is equal to 4. Is equal to 4. So you see, after rationalizing what was in the square root, what was inside the square root sign, it made the problem very simple for us to solve. Provided if we had put this one into the expression right away, you could have encountered a lot of what calculations, or maybe you could have do a lot of calculations could have been done as compared. Just for when you compare, when you put this one into the expression and the other one that we just plug into the expression, the number of workings or the calculations that we're going to do, this one will bring out a lot of let's say a little bit tedious calculation as compared to the one we put into the expression together, 4. When you put this one, you're just going to get the same 4 here, and the other one also give you the same 4 here. But to go a little bit faster, we chose to simplify. So when you get problems of this nature, one, you can choose to, if only you can deal with the algebra that will come across, you can choose to put the whole of this into this one, and you're still gonna get what? 4. Or you can choose to reduce it to its lowest term before you put it into the expression. Okay, all right, that's it guys. Please, if you like this video, kindly give it a thumbs up, subscribe and comment. Thanks for watching.